Okay, good morning. It's Friday morning, everybody. Woohoo, yeah. So we're going to skip chapter 5 and 5 and 6.1. We're going to go straight to 6.2, okay? So I'm on page 194 right now, page 194. And what we're going to do is talk about this thing called, first, about a thing called a theorem. So we're actually doing geometry. I know it's called geometry class. We're actually doing geometry now. So we're going to talk about a thing called the perpendicular bisector theorem. There goes my phone. It's my daughter. Anyway, talk to her later. So what is a theorem? A theorem is just a special name for a math rule. So theorem is a special name for a math rule, okay? And we use theorems mostly in geometry, okay? So here's our perpendicular bisector theorem. It's a math rule that can be proven, okay? A math rule that can be proven. Now we're not going to do any proofs, so don't worry if your parents are, gosh, you guys doing proofs. We're not doing proofs. So, so irritating. Anyway, perpendicular bisector theorem, okay? In a plane, that's a flat surface, if a point lies on the perpendicular bisector, okay, that's this point right here. So this line right here is a perpendicular bisector, okay? The word perpendicular means it comes at 90, perpendicular, 90 degrees, and bisector means cuts in half, right? Okay, let's go back through this since I got interrupted already. So perpendicular means at 90 degrees. Bisector means it cuts it in half. So it cuts it in half. So this line right here, let's call it line L, is the perpendicular bisector. Okay, that line L is perpendicular bisector. So it cuts it in half at 90 degrees. This line right here cuts this line segment AB. So AB got cut in half. That's why this piece is equal to this piece. See the little dashes? That piece is equal to that piece. Okay. And that means P is a midpoint, okay? If then we got some other point right here, C, that's on that line. Let me draw a picture. So if we've got, let me go ahead and draw what's going on. I got a point A, B, and I draw this line going through it at 90 degrees, cuts it in half. Well, here's what it's saying, okay? If I got some other point anywhere here, okay, then what happens is if I were to draw this triangle, okay, I'm just going to draw a triangle so you can see it. If I draw this triangle, okay, then this side here is equal to this side here. That's all they're saying. Okay, one more time. I've got a line that cuts another line segment in half at 90 degrees. Okay, so this line cuts in half. That's equal to that. If that's the case, then any point along this line here would make these two sides equal. So we get this side equal to this side, and that's what they say right there, that CA is equal to CB, okay? Now, a converse means just saying the opposite, okay? So the converse is just saying the opposite of, okay? So converse is like the opposite. So the converse of the perpendicular bisector theorem. So they're saying this, if these two sides are equal. Let me draw a picture, okay? So I got this line segment here, right? In a plane, if a point is equidistant from the endpoints of a segment, and it lies on the perpendicular bisector, okay? So let's say we've got, this is a perpendicular bisector, which means this side's equal to this side, and it's at 90 degrees, okay? And let's say that, sure enough, that this side is equal to this side. Then this line must be a perpendicular bisector. It's just saying the opposite, okay? Okay, shift over to the other one, okay? Oh, you guys can't see that. There it is. Okay, shift over to the other side. So the other side is called the angle bisector. So to be an angle bisector, it means that we're going to cut the angle. We're going to cut the angle in half. Angle bisector. So the angle is cut in half. All right, so take a look at this picture. Here's a line, and the line, this ray right here, is going to cut the angle in half, okay? So if a point lies on the bisector of an angle. This is my AD is my bisector. AD is my bisector because it cuts it in half, okay? And if that's the case, then what happens is then this angle is equal to that because it's a bisector. So that means that this angle here has to be equal to this angle here because it's an angle bisector, okay? So I know, and it's going to say that we know that this angle BAD BAD has to be equal, or this thing called congruent, to angle CAD. Okay, these two angles are equal. If that happens, then, okay, and then there's a point that's equal distance, like if this side's equal to this side, then it must be perpendicular, okay? Let me draw a different picture, okay? So it's like this. Okay, I got an angle. Okay, got an angle, right? I cut it in half. Cut it in half. Okay, I'm going to cut it in half. That means that this angle is equal to this angle. Cut it in half, all right? Then what happens is if you got some point out here that's equal distance to two other points, right? If that's equal to that, then that must be 90 degrees. It's going to be perpendicular. Must be perpendicular, okay? All right? Again, the converse just says just the opposite. If it is perpendicular, then that must be an angle bisector, okay? So if you've got this line, this ray that goes through this angle, if these two are equal, and that's perpendicular, then these angles must be equal, and it bisects the angle, okay? That means that this angle is equal to this angle, so that I can say that angle BAC is this congruent to angle CAD. Okay? Now we're going to keep talking about it, okay? Let's keep going. So, if I know that, then let's go ahead and take a look at the notes. All right, so the notes today, okay? Perpendicular bisector theorem. We just learned that, okay? So, I'm going to draw a picture. Just draw a picture. Okay, today is bisectors. We know that. We just talked about the fact that if we had a line segment, okay? Line segment AB. Okay? And if we had a perpendicular bisector, so the perpendicular bisector is a line that goes through, okay? Let me use this color. Okay, here's my perpendicular bisector. Okay, let's call it line L. Okay, this is line L. L is the bisector. So L is the line L is the and I like the symbol perpendicular bisector. If that's the case, then I know two things. Word perpendicular bisector. I know two things. This side is equal to this one because the bisector. That's equal to this. Let's call this point. I don't know. Let's call point. They like P, so we'll call it P. Okay, point P. So I know that right off the bat that AP is going to be congruent. This word congruent to AP to PB. Okay, I know that. Then. That's the case if we got some point on it anywhere, okay? Some point anywhere on it. Let's put a point like right about here. Let's call this point C. Then if we're to draw these lines in, then that side must be equal to that side, okay? Converse is just the opposite, okay? So if we know that, let's take a look at it, okay? So here's what we know. Let's use it. I know this side is equal to this side, 10 and 10, right? I know that's a perpendicular bisector, so that means that this SU, I know SU must be equal to UT. Okay, I know this side's equal to this side. Let me highlight that, okay? I know this side has got to be equal to this side, okay? Now if that's the case, let's solve for the value of x. I can do that. So pretty easy math. SU is 2x plus 2, and UT is 3x. Okay, this is easy solving. Easy solving. Minus 2x minus 2x, I've got a 2 equals a 1x, or x equals 2. Now that's not the answer. That is not the answer. That is not the answer. Because you've got to take 2. We want the value of SU, so we have to plug it in, right? So we plug it in. And then SU is going to be 2 times 2 plus 2, because I plugged 2 in for x. 2 times 2 is 4 plus 2 is 6. So the answer is 6. SU equals 6. Okay? All right. Example 2. Find the equation of the perpendicular bisector. Okay, so let's go ahead and figure out what the heck does this mean. Let's graph AB. 1, 2, 3, 1, 2, 3, 4, 5. There's A. And 1, 1, 2, 3. Okay, now I'm going to go ahead and grab a ruler and connect these, okay? All right. Let's see if I can draw it. Okay, now let's think about this. What does the word perpendicular bisector mean? So first of all, bisector. I know that bisector is like cutting it in half. So let's find the middle, the midpoint. Let's find the middle or the midpoint. Well, that's easy. Let's see if I count this. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Down 8. Down 8 over 4. Let's go half of it. 1, 2, 3, 4. 1, 2. That's got to be the middle. Do you see how that's right in the middle? Okay. So I've got the bisector. Now if it's perpendicular, that means the line's going to look like this, okay? It's going to look like this. Okay, so if I know a couple of things, let's figure out the slope of AB. Because I need to find which way to go on this line, right? It's like that, but let's get it to be exact. So let's get the slope of AB. So if it's down, looks like it's down 2 over 1. Down to a slope of AB seems to be down 2 over 1. Let's check it out. Down 1, 2 over 1. 1, 2 over 1. Down 1, 2 over 1. So the slope is down 2 over 1. So it's perpendicular slope. Okay. M perpendicular. Let me go ahead and give you a little bit of help on that. This means that's the symbol for perpendicular. Perpendicular slope. Okay. So that's going to be just going to be the opposite of that. So the perpendicular slope is going to be a positive 1 over 2. All right, I can do that. So go ahead and draw that in. Opposite slope, you see it? Perpendicular. So I'm going to go up 1 over 2, up 1 over 2. Okay, and there it is. That is the perpendicular line. Perpendicular bisector. Perpendicular, it's got opposite slope. Bisector, because this is the midpoint, so this side is equal to this side. And now, what if I need that equation? If I need the equation. Oh man, this is taking me back to algebra. If I want the equation, it's a line, right? So the equation of a line, I don't know if you remember this, but if you don't, I'll write it down and you will. We're going to use the y equals mx plus b, because that's the equation of a line, right? Well, need the equation line of this one, so it seems like it goes up 1, y equals up 1 over x, up 1 over 2, up 1 over 2x, and it seems like it goes through at 1 1/2. Oh darn it, 1 and 1/2. There we go. So that's we drew the perpendicular bisector, we drew it, went through the middle, cut it in half, and we knew the equation was up 1 over 2, y equals a 1 1/2 x plus 1 1/2, because it goes through 1 1/2. Okay? All right. So let's do the angle bisector. Okay? So the angle's not hard either. So the angle bisector theorem says this. If you have an angle, I'm going to draw an angle in. It says this. If you have an angle, any angle, okay? And then we bisect the angle. It means we're going to cut it in half. Let's see. About there maybe. So if I cut it in half. Okay, let me label. Got my A, B, C. If I cut it in half, then let me make this be point P. So then I know that this angle here, this angle is equal to this angle, because I cut it in half. So I'd say that angle A, I'd say the measure of angle, see the M, measure of angle, ABP, ABP, ABP is equal to the measure of angle CBP. I know that. So then if we happen to have a point P and it was equal distance, let's say that the distance here is equal to the distance there. Okay, okay. If we knew this was equal to that, then we know it was perpendicular. And the converse says just the opposite of that, okay? So let's take a look at our last example, example 4. It's pretty easy, actually. So here's what we know. We know that these two angles are equal, so this must be a bisector. We knew those two angles are equal, so it must be a bisector. Cuts it in half. And we know if that's perpendicular, those two sides are equal. Perpendicular, perpendicular, these two sides are equal. So let's find, we're going to find the length of a BD. So let's set them equal. This side has to be equal to this side, okay? So let's go 3x plus 1 equals a 5x minus 1. Solve for x, minus 3x minus 3x. Okay, 1 equals a 2x minus 1 plus 1 plus 1, right? I've got 2 equals 2x, divide by 2, x is 1. Okay, now that's not the answer. We need BD. So BD is here, so let's take our 1 and plug it right in here. 1 is not the answer, we need BD. So we're going to plug it in. We're going to have a 3 times a 1 plus 1. Just plug it in 1, we get 3 plus 1 is 4, so BD must be 4. That's the answer. Okay, so I will talk to you for sure on Monday. We'll go over again more of this and what a theorem happens to be. So I will talk to you Monday. Good luck. Please do the homework. Okay, and that's all I got.